Yeah, welcome students. Let's have the paper discussion, part test 11. So I'm going to discuss physics solution. So in this question, we have nth shell, n number of shells on each on charge q, 2q, 3q and so on of radius a, 2a, 3a, and what we have to find potential on nth cell. So potential on nth cell is due to n number of shell, right? So we can write first potential due to first shell. The potential due to first shell is kq upon na. And why we are writing na? Because we are finding on nth shell. Suppose there are n number of shell, and if you are finding potential here, so due to each shell you have to consider this distance. Then potential due to second, k to q upon distance remains same, plus k nq upon na. So just take kq by na common. So what we will get, 1 plus 2 plus 3 plus 4 up to n. And we know the sum of this series is kq n a n into n plus 1 by 2. This is the sum of this series. So what we will get from here, and cancel out, the value of k is 1 upon 4 pi epsilon naught q n plus 1 upon 2a. So which option is correct? Option D is correct. Yeah. So for solid sphere, what you must remember, if electric field inside solid sphere is rho r by 3 epsilon naught. So it is, field is positive if charge density is positive, and if charge density is negative, field is negative. So look at this point. At this point, this is r1 vector and this is r2 vector. So at this point, field is due to two spheres. One because of plus rho, second because of minus rho. And let's say this is the distance. Let's take this is d vector. So at point O, so at point O, E net is rho r1 upon 3 epsilon naught minus rho r2 upon 3 epsilon naught. Why I am writing here minus? Because this is negative charge density. So take rho 3 epsilon naught common, r1 minus r2. And from here we can easily write r1 is r2 plus d. This is vector law of addition, r1 r2 plus d. So d vector become r1 minus r2 vector. So what we are getting, E net become rho d vector upon 3 epsilon naught. So which option is correct? Option A is correct. In this question, a charge q is placed or located at height L by 2 above the center of a square of side L. Find the flux through this square. So we have two methods to find the flux. First, you can take this small strip. You can find electric field here, which is making some angle theta with it. Take dq is equals, sorry, d phi is equals to E dot ds, but this will be lengthy method. So what you can consider, कि this face is a part of cube, and charge q is placed at the center of cube. Charge q, charge q is at the center of cube. So by using Gauss law is total flux is q enclosed by epsilon naught. So q by epsilon naught. And since this flux is passing through six faces, the flux through one face become 1 by 6 q by epsilon naught. So which option is correct? Option A is correct. So in this question, what they are asking, electric potential at any point on the axis of dipole. So you must know that dipole is a combination of two equal and opposite charges separated by a small distance d. So all those points which are on the axis of this are axial points, and on axial points potential is kq by r cube if r is the distance from the center, or here they used x, so we can say, sorry, this is not cube, this is r square. So option B is correct. Question number 30. In this, charge q is distributed uniformly over the circumference of ring of radius 3 meter in xy plane with the center at origin. Find the electric potential at point P. So electric potential of point B due to ring is kq upon under root r square plus small r square. This is radius and this is center from distance from center, distance on axis from center. So what we will get, b equals to value of k is 9 into 10 power 9 into q is how much, q is 10 into 10 power minus 6 because it is given in microcoulomb under root 3 square plus 4 square, which will give us 9 upon 5 into 10 power 4. So we are getting 1.8 into 10 power 4. So option A is correct. In this question, two conducting thin shells of radius r and 3r are given. The outer shell carries a charge q, the inner shell is neutral. Find the charge that will flow from inner shell to the earth after the switch S is closed. Okay, so if S is closed, it means inner shell is grounded. And the meaning of if you ground any conductor, potential on it is potential of the inner shell must be 0. So I don't know how much exact charge is available on it. So let assume q dash on inner surface and q is on outer surface. What we are assuming, q dash, assume on the inner shell. So now what is the potential at inner shell? Potential at inner shell, let's take any point. Take this point B. The potential at point B is due to two shells. One is due to a small shell kq dash upon r, plus another one is from outer shell 3r. And you must remember this thing, ki potential, if this is the radius r, charge q, then potential at all point inside this is kq by r. That's why we are writing here 3r. So what we are getting, this potential is equals to 0. Why? Conductor is grounded. So from here you will get kq dash upon r is equals to kq upon 3r minus kr cancel. What we will get, q dash is minus q by 3. Now question is how much charge flow from shell to earth. So initially this shell is neutral, means initially having zero charge. When you switched on the, when you close this switch, it is grounded. Now the charge is minus q by 3. So how much charge flow from shell to earth? Q by 3. That's why it acquired minus q by 3. In this question, three charges of these magnitude are placed on the corner of equilateral triangle having side 50 centimeter. So what is the potential energy of the system? So how we can calculate potential energy? We know potential energy between two charges or due to the interaction between two charges is kq1 q2 by r. So here potential energy is, let's mark the number of charge. Okay, it is already given. Potential energy, interaction potential energy between 1 2 plus 1 3 plus 3 2. So we, separation remain a, so we can take k upon a common. So here we will get q1 q2 plus q1 q3 plus q3 q2, sorry, we will get q1 q3 q2 q3. Okay, let's put the values. Value of k is 9 into 10 power 9 upon a is given how much? A is given 50 centimeters, so 50 into 10 power minus 2. Now q1 and q2 are 200 into 10 power minus 12 because charge is given in microcoulomb. q1 and q3 is 300 into 10 power minus 12 plus q2 and q3. Q and q3 will give us 600 into 10 power minus 12. So what we are getting? We are getting 9 by mm, mm, 9 by 5 into 10 power 10. Here we are getting 2 plus 3 plus 6 into 10 power minus 10. So we will get from here, this become 6 9 11, 11 11 into 9 upon 5 equals to 99 upon 5, which is 19.8 joule. So this is the correct answer. Okay, electric potential at a point. V is given. Find the field at x equals to 1. So if you remember the relation between field and potential, basically this question is conversion of potential to field. So relation between field and potential is electric field is negative gradient of V. So here we can write, here we have only one coordinate, so directly I can write Ex equals to minus del V by del x. So just differentiate it. On differentiating, what you will get, 10 plus x, 15 upon x square plus 5 by x cube. So from here you will get minus 10 by x square minus 30 by x cube minus 15 by x power 4. So Ex at x equals to 1 become 10 plus 30 plus 15, so 55. So E become 55 I cap volt per meter. Yeah, to solve this question, let me ask you, have you solved this type of question? Y is under root 1 plus under root 1 plus under root 1 plus under root and up to infinity. So in those type of question, what, how we solve these type of questions? So what we can put ki this value is also y. So we can put it like this, 1 plus y. So we got one quadratic equation and we can solve the value of y. So similarly, what we are doing here, let's cut this circuit from these points and let the resistance of this portion be R naught. So what we get, R naught, R. So now this equivalent of R naught, R is equivalent of this portion. Equivalent of this portion is, these are in series, so their equivalent is R naught plus 2R. And this R naught plus 2R is in parallel combination with this R. So R equivalent become R equivalent become R naught plus 2R into R upon R naught plus 2R plus R. Similarly, using parallel combination property, R equivalent in parallel combination is R1 R2 upon R1 plus R2. So this is the equivalent, and this equivalent is equals to what we are assuming? We are assuming this as R naught. So is it same branch? Yeah. So this is equals to R naught. Similarly, whatever we have done here. So what we are getting from this, R naught R plus 2R square equals to R naught square plus 3R R naught. So equating this, we will get one quadratic equation, R naught square plus 2R R naught minus 2R square equals to 0. On solving this quadratic equation, you will get R naught equals to minus 2R plus minus b square become 4R square minus 4ac, minus 4a is 1, c is minus 2R square upon 2. So from here, negative value of R naught is not possible, so you will get R under root 3 minus 1. So this is the correct option for this question. So in this question, we have to find the equivalent across A and B. So we can redraw this circuit like this. A, B. This is 2 ohm, 2 ohm, 2 ohm, 2 ohm. This is 2 ohm. So these two are in parallel combination. The parallel combination will give you 1. These two are in parallel combination. So this will give you 1. And these two, this 1 and 1 become in series combination. So you will get 2. How? So let's mark it. What you will get on further reducing this circuit, you will get 1 ohm equivalent of these two, then 1 ohm equivalent of these two. So it become, so in series equivalent become R1 plus R2, so it become 2 ohm and 2 ohm. Now these 2 ohm resistors are in parallel combination, and for parallel combination net equivalent become 1 upon 2 plus 1 upon 2 equals to 2 upon 2 equals to 1 upon 1. So R equivalent become 1 ohm. So in this question, we have to find the current across this shell. So if you observe carefully, all the branches are in parallel combination. Parallel combination means each branch potential difference is same, which is 25. So what we are going to do, we are going to calculate individual current in all the branches, then we will add up all the currents. So look at this branch. Potential difference between C and D is 25 and one shell is there of 30 volt. So can I write I1 is equals to 25 plus 30 upon resistance is 11, that become 55 by 11 equals to 5 ampere. I2 is equals to 25 minus 20. You have to focus on here, minus 20. Current is going like this is plus, this is minus, so we are leaving negative side, upon 5, so it become 5 upon 5 equals to 1 ampere. Now talking about I3, I3 become again potential difference across it is 25. 5 volt battery is there, so effectively it become 25 plus 5 upon how much resistance, 10. So 30 upon 3 is equals to 30 upon 10, 3 ampere. I4 similarly become 25 minus 10, this is the opposite polarity, upon 5, so it will give you 15 by 5, which is 3. So total current in this is, apply junction rule here. Junction rule, total current in this become I1 plus I2 plus I3 plus I4. So current across 25 volt cell is how much? 12 ampere. So 12 ampere is the correct answer of this question. In this question, three charges are placed on a straight line such that Q is somewhere in between Q1 and Q2 if the system of charges is in equilibrium. See, you have to focus on it. The system is in equilibrium. Means all force on all charges is net force on all charges is zero because system is at zero. System is in equilibrium. So tell me one thing, if you placed here positive charge, is q1 will be in equilibrium? No, because q1 will experience repulsive force from q1 both of these charges, q and capital Q2. So positive charge is not possible. The only possible is negative charge. So let's apply equilibrium condition for Q. Equilibrium condition for Q is net force on Q is 0. It means K Q1 Q upon R minus X whole square is equals to K Q2 Q upon X square. So from here what we are getting, R minus X upon X is Q1 upon under root Q1 upon under root Q2. This is one condition. Now apply equilibrium condition on 2 charge Q2. So how many forces are acting on Q2? One is attraction force due to Q and second is repulsive force due to Q1, and these two must be equal and opposite. So K Q 2Q upon X square is equals to K Q1 Q2 upon R square. So from here what we are getting? We are getting from here we are getting R by X. From here we can calculate R by X. From here we can calculate R by X, and R by X we are getting R by X equals to R by X equals to Q2 cancel, under root Q1 upon under root Q. So equation 2, this is our equation 1. So from equation equation 1, we can write r by x minus 1 equals to under root q1 minus q2. From equation 2, put the value of r upon x, you will get under root q1 upon under root q minus 1 equals to under root q1 upon under root q2. So here you will get the value under root q1 upon root q is equal to under root q1 plus under root q2 upon under root q2. So what is the answer? Then q become square of q1 under root q2 upon under root q1 plus under root q2 whole square. So which option is correct? C option is correct. Yeah. In this question, a satellite can be in geostationary orbit. Geostationary orbit. Satellite revolve with same angular velocity. And we know time period time period square is proportional to radius cube. This is the condition. So from here we can write t1 square upon t2 square is equals to r1 upon r2 cube. And time we can write in angular frequency like this: 2 pi upon omega 1 upon 2 pi upon omega 2 whole square equals to r1 upon r2 cube. So we will get omega 2 upon omega 1 equals to r1 upon r2 cube. Now what they are asking, if angular velocity is twice, then the satellite can be in geostationary orbit around the earth if the distance from the center. Okay, omega 2 become 2 times omega 1. So what we are getting, r2 become r2 cube is 3, this is 3 by 2 r2 upon r1, sorry, 3 by 2. So this become 1 by 2 is equals to r1 upon r2 3 by 2. So what we can, how we can write it like this, we can write it like in this way also: 2 power 2 by 3 is equals to r1 upon r2. So from here r2 we are getting r1 upon 4 power 1 by 3. So this is correct option. In this, water is heated by the resistor, by the electric circuit. So basically what we can relate, the heat generated in resistor, which is V square by R effective into time, is equals to M S delta T. This is change in temperature, this is specific heat of water, and this is mass. So this, you have to remember from calorimetry. Now what we need to focus, if it is connected between r1 and between 1 and 2, if power supply is connected and between these 2 points like this, then what is r effective? R effective become, in this case, see, in this case this become balance Wheatstone bridge, balance Wheatstone bridge. So this will not part take with this will not take part in conduction. So these two are in series combination, their equivalent become 2r. These two are in series combination, their equivalent become 2r. And this 2r and this 2 are in parallel combination, so r equivalent we will get in this case 1 upon 2r plus 1 upon 2r. So 2 upon 2r, R equivalent is R. But in this case, when the power supply is between 1 and 3, for 1 and 3, this resistor and this resistor is in series combination, so its equivalent become 2R. This 2R, this 2R and this R is in parallel combination, so their equivalent become R equivalent, R dash equivalent become R 2R upon R plus 2R. So 2R by 3. Now this 2R by 3, this 2R by 3 is in series combination with R. So R equivalent double dash become R plus 2R by 3. So what we are getting? We are getting 5 by 3 R. Now this 5 by 3 R, this 5 by 3 R is in parallel combination with this R. So R equivalent, this is R equivalent in 1, this is R equivalent 2, we will get 5 by 3 R into R upon 5 by 3 R plus R. So from here we will get 5 by 8 R. Now putting R equivalent for both the cases, what we will get? V square T upon R1 equivalent is equals to ms delta T, where m is given 500 grams. In second case, V square T upon R2 equivalent is equals to ms delta T. Ms delta T cancel out. V square T cancel out. So what we are getting? We are getting m equal to 500 into 500 into R1 equivalent upon R2 equivalent. R2 equivalent. So from here 500 into R upon 5 by 8 into R. R cancel, this become 100. So what we will get? 800 into 100 into 8, 800 grams. So this is the final answer. Yeah, in this question, parallel plates are given and partial region are filled with different dielectrics. So if you observe, these two layers are in series combination, and in series combination, charge on each capacitor, each capacitor remain same, same. Okay, so Q is equals to C V. So from here we can write C1 V1 is equals to C2 V2. So V1 upon V2 is C2 upon C1. This is one condition we are going to use here, and in the case of parallel plate capacitance C is equals to K epsilon naught A by D. So C1 become K1 epsilon naught A by D, and C2 become K2 epsilon naught A by 2D. So from here C1 upon C2 will be K1 upon K2 by 2, or 2 K1 upon K2. So the value of K1 is how much? 2, and the value of K2 is 6. So what we are getting? C1 upon C2 we are getting 4 by, or directly we can write 2 by 3. So V1 upon V2 is C2 upon C1, and C2 upon C1 become 3 by 2. So from here we can say option D is correct. In this question, the density of a solid sphere is given. This is not uniform density, this is variable density. where r is the distance from its center. The gravitational field due to this sphere at a distance 4r from its center is E and G is the gravitational constant, then the ratio. Okay. So what they are asking, this is given, and they are asking field at this point, which is at 4r distance. So since we know the field is, electric field is Gm by r square. I'm taking the magnitude Gm by r square. But mass is not given. Mass is not given. So how we can find mass? So mass we cannot find directly, rho into 4 upon 3 pi r cube. Okay, sir, mass is density into volume. Why we cannot find it like this? Because rho is not constant. Rho is not constant. So what we can do, we can take a small spherical element whose radiuses r and thicknesses dr. So this is a small element, a small mass element, a small mass element. So for this, what we can consider, कि volume of this small mass element is area into thickness, and area is 4 pi r square. Thickness, this is area, and thickness is dr. So dm become rho, dm become rho into dv. So rho is how much? 20 r square upon capital R square into 4 pi r square dr. So students, mass become dm, and limit of integration, remember in this case limit of integrations are not from 0 to 4r. Why? Because mass is up to here, from here to here, so limits are 0 to r. Okay, so calculated, I'm putting constant out of the integration, 24 pi upon r square integration of r power 4 dr from 0 to r. So it will give you 24 pi upon r square, and integration of it become r power 5 upon r power 5 upon r power 5 upon r power 5 upon 5. Okay, so it become 4. So basically what mass we are getting, 16 pi r cube upon, yeah, 16 pi r cube. This is a mass. Now find electric field at any point. Electric field at any point we can find by this formula, where distance is 4r. So electric field is G, m is 16 pi r cube upon 16 r square. So what we are get, 16 16 cancel, r square r cube will get r. So from here what we are getting, e upon gr is, e upon gr is pi. So correct answer of this question is pi. So in this question what is given, resistivity is varying. So let's take this a small element, this is small element, resistance of a small element, resistance of a small element. We know resistance is rho L. L is dx by A, and rho is how much? Rho naught x dx by A. So total resistance become integration of dr from 0 to L. This length is L. So put the values, rho naught x dx upon A, integration 0 to L. From here we will get rho naught L square upon 2A. Now current in circuit, current is V by R. So what we will get? We will get V 2A upon rho naught L square. So From here we are getting current equals to 2 AV upon rho naught L square. Now potential drop across dx length, dv is equals to I, dv is equals to I dr. So put the values, AV upon rho naught L square, and what is dr? Dr we know from this equation, rho naught x dx by a. A cancel, rho naught cancel, so dv we are getting 2v x dx upon L square. This is equation 1. So I'm writing it here from equation 1. Can I write like this? dv by dx is equals to 2vx upon L square. And my question is, what is dv by dx? dv by dx is nothing but E is equals to minus dv by dx. So magnitude of field become 2v L square into x. Yeah, and this question we have to find the current in I2. Okay, let's assume current I1 is going from here, I2 is going from here, and sum of the current, see, according to the loop rule, in this loop current remains same, so I2 must be in this wire also, and I1 here. So entire current whatever is coming from this wire is entering into this wire, and whatever the current is coming from this battery is passing through it like this I2. So current in this remain 0. Yeah, this question is based on charging of capacitor. Charging of capacitor. So if you remember, if you connect one battery with a resistor R and capacitor of capacitance C, the charge at any time is Q equals to Q naught 1 minus 1 minus E power T by RC. So Q naught is E by R, right? Q naught is, sorry, Q naught is E by C. Sorry. Q naught is C E. Yeah. Now in this question, when capacitor is connected with up to at t equals to 0. So at t equals to 0, capacitor is fully charged, fully charged in first circuit. So can I write charge become Q naught become C E. Now at t equals to 0, this is connected with 2. So at t equals to 0, it is connected with 2, and at t equals to infinity, capacitor is fully charged up to what charge? This time full charge become, maximum charge become for circuit 2. This is for circuit 1, this is for circuit 2. Q naught become 2C 2EC, and this charge will exponentially grow. So the correct answer is this. The charging of a capacitor is, the graph of charging of capacitor is this. This is Q naught, this is I. So this is the correct graph. Okay, in this question, suppose sun is here and planets two positions are given, r1 and r2. R1 is maximum distance, this is r1, and this is r2. So we know angular momentum remain conserved. Angular momentum angular momentum remain conserved. Okay, so let's check it. Angular momentum m v1 r1 is equals to m v2 r2. So from here I can write v2 is equals to v1 r1 upon r2. Second thing, energy also remain conserved. energy remain Energy remains conserved. So from here can I write total energy at point 2 and at point 1 is same. So at point 1 is half m v1 square minus g m upon r1 is equals to half m v2 square minus g m upon r2, right? So just put the value of v2, because see we need angular momentum we can write m1 m v1 r1. R1 is given, we need this v1, so v1 we will calculate from here, put the value of v2. Cancel out, right? Yeah, cancel out. Half v1 square minus v2 square is equals to gm 1 upon r1 minus 1 upon r2. So from here 1 upon 2 we can take v1 square common by putting the value of v2. 1 minus r1 square upon r2 square is equals to gm r2 minus r1 upon r1 r2. So from here what you will get? You will get half v1 square r2 minus r1 r2 plus r1 upon r2 square is equals to gm r2 minus r1 upon r2 r1. So this term will cancel out, 1 r2 cancel out. So from here we will get v1 is equals to under root 2gm 2gm, right? And r2 upon r1 plus r2 into r1, right? So what is angular momentum? By using this equation, L is m v1, put the value of v1 to gm r2 upon r1 plus r1 plus r2 into, this is into r1. So r1 will come inside, you will get L equals to m under root 2 gm r1 r2 upon r1 plus r2. So this option is correct, option D is correct. So in this question what is given? A non-uniform electric field is given, and since electric field is in I cap direction, so remember this thing, electric field is in I cap direction where k is a constant. Okay, each side of the cube length is given, it's lie along the coordinate axis. All right, so since electric field is in I cap direction, so the electric flux due to this and this front side, this face and this back side face is 0. Phi due to these is 0. Why? Because for these four surfaces, electric field and area vector are perpendicular to each other, are perpendicular to each other, right? So electric field is only passing through these two faces, 1 and 2. So let's mark it first phase, mark it second phase. So for first, normal vector is in minus I cap direction. So area vector become L square minus L square I cap. And for first phase, x value is the value of x is 0, so e become e naught I cap. E become E naught I cap. Okay. So electric flux phi 1 become we know E dot area is, so flux we will get E naught L square minus E naught L square. For second surface, n cap is in I cap direction. This is the perpendicular. This is uh, perpendicular to this surface. And here for this surface, the value for this face, this is in yz plane and x ka value is L. So electric field become E naught plus K L I cap. Then flux phi 2 become E naught plus K L square. So total flux is, according to Gauss law, q upon epsilon naught, q enclosed upon epsilon naught. So how much we are getting? E naught L square plus K L cube minus E naught L square equals to q enclosed by epsilon naught. So this term will cancel out. What we are getting? E enclosed is epsilon naught K L cube. So from here, what we can find? We can find n value is 1. N is 1. In this question, two conducting spheres of radius r1 and r2 are given, are charged to the same surface charge density. Both have same surface charge density. So sigma 1 is equals to sigma 2, right? Equals to sigma. And since these are conducting spheres, you can do it in two ways. You can find charge and you can use that formula. Electric field near to the surface become kq upon r square. But since these two are conducting spheres, for conducting spheres, we know for conductors, electric field at surface, electric field at surface is always sigma by epsilon naught. So E1 is sigma by epsilon naught, E2 is also sigma by epsilon naught. So from these two, what we are getting, the ratio of electric field is 1:1. So correct answer is 1. So we can redraw this circuit into this format. How we are getting this? See, this point and this point have same potential as V. So these two capacitors C1 and C3 are connected with B. So C1 and C3, this plate is connected with B. With A, C2 and C4 are connected. With A, C2 and C4 are connected. One plate of C4 is directly connected to B. C4 is directly connected to B. And C3, one plate is connected to B. C1 also one plate is connected to B. And mark this point C. And this point is C. C2, one plate is connected to A and one plate is connected to C. And with C, C1 and C3 plates are connected. So in this circuit, each capacitor is of 9 microfarad and we have to find equivalent capacitance. So if you observe, C1 and C2 are in parallel combination. So C equivalent of C1 and C2 becomes C1 plus, sorry, C1 and C3. C1 and C3. C1 C3 is equals to 2C, where C is 9 microfarad. Now, now C2 is in series with equivalent of C1 and C3. So C equivalent C equivalent of C, let's take it C dash equivalent. So C2 C13 upon C2 plus C13. So C2 is C, C3 is 2C upon C plus 2C. So we will get 2 by 3 C. And C4 is in series in parallel combination with C equivalent dash. So final C equivalent become C equivalent dash plus C4. So 2 by 3 C plus C, which is 5 by 3 C, and the value of C is how much? 5 by 3 into 9 into 10 power. Oh, they are asking in microfarad itself, so directly we can write microfarad. So 3, it will give us 15 microfarad. So answer of this question is 15. In this question, a satellite is moving in a circular orbit around the Earth radius equals to half of the magnitude of escape velocity from the Earth. So if the satellite is suddenly stopped, means kinetic energy becomes zero in the orbit and allowed to fall freely onto Earth. The satellite hits the surface with what? So what is given in the question? Orbital velocity is half of escape velocity. And we know escape velocity of Earth is g 2 gm by r. So also we know orbital velocity is gm by r equals to 1 upon 2 gm by r. So from here what we are getting, on squaring it we will get gm r equals to 1 upon 4 into 2 gm by r. So from here we are getting r equals to 2r. This is radius of orbit. Radius of orbit. So now if at this moment satellite stops and allowed to fall freely, so what is going on? Satellite is here at distance how much? 2r. So here, and satellite will strike on the earth's surface. So potential energy loss in potential energy is equals to gain in kinetic energy. So from here, how much is the loss in potential energy? So loss in potential energy is gain in kinetic energy first half mv square, and loss in potential energy is g m by r minus g m by 2r. This is potential energy P at surface, and this is at distance 2r. So from here what we are getting, half mv square equals to g m by 2r. So m cancel, 2 cancel. From here we will get v equals to under root gm by r, and we know multiply and divide it with r. So what we are getting, this is gm by r square and into r. So you will get what we have to use, 9 10 into radius of earth is given, which is, but we have to put it into meters, 10 power 3 meter. From here we will get velocity in terms of meter per second, and on converting into kilometer per hour you will get 7.91 kilometer per hour. So close approximation, approximated answer is 8 kilometer per hour. In this question, what is given? A mass m is on the axis of ring. So this is a ring of mass capital M. The force experienced by the particle, and we know force, gravitational force on any particle is mass into gravitational field, mass into m into e. So if mass is distributed over the ring at of radius r, and we know this field is maximum, gravitational field, gravitational field is maximum at r equals to uh, at x equals to r upon root 2. This you have to remember कि electric field, gravitational field of ring is maximum at this distance. So what is given? R square n is n into x square. So just put the value of x, r by root 2 whole square. So what we are getting? N r square by 2. So from here r square equals to n r square by 2. This corresponds to n equals to 2. So what you need to remember, at which value field is maximum. Force is maximum at the point when field is maximum. Okay. So force is maximum when field is maximum.